Hi guys, welcome to Cola Teaches Math. So I wanted to go over how to use the second fundamental theorem of calculus graphically. So a lot of the questions are going to start out with a lot more words, but we're just going to jump to it. So this is the graph of f that I produced in front of us, and then I give you an integral and I give you a whole new function g, and I say g of x is the integral from 3 to x of f of t. And what I like to do right away in my class is I tell my class, let's apply the second fundamental theorem, which means we are going to derive the integral. So the derivative of g is g prime. And our checklist needs to be, the top bound needs to be a variable, a function of x. And everywhere we see a t, we're going to replace t with that variable. So f of x times the derivative of x, which is just 1. And then we say in class, let's put all of this in a box because it's all really important here. And then we go up here and we say, not only is this the graph of f, it's also the graph of g prime now. Because if you notice down here, all of the questions are asking me about what g does. And this all comes back to curve sketching, okay? So I'm gonna highlight two things so I can reference some colors. So let's highlight this in pink, so the integral in pink, and then I'm going to highlight in orange the derivative. So if letter A wants me to find g of 6, we are going to use the pink as my roadmap because the pink that I highlighted references g, which means we are going to now replace x, this blue x, with 6. So my integral is going to be the integral from 3, replace x with 6, f of t dt. Well, the integral is the area under the curve. So this black integral right here is asking me to find the area under f from 3 to 6. So we're going to go on up here and we're going to say, okay, let's find the area from 3 to 6. We're going to be finding the area of this pink triangle, base times height divided by 2. So the base is 3, the height is 3, so this is going to be 9 halves. So this is going to be equal to 9 halves. All right, next, g prime of 6, we're going to use what I highlighted in orange. It's equal to f of 6. Well, this is the graph of f. So f of 6 is just going to be 0. When x is 6, y is 0. And then last but not least, g double prime of 6. Guys, if this is the graph of g prime, then g double prime is going to be the derivative, the slope of g prime. So we're going to find the slope of this straight line that I'm highlighting in purple. Now, guys, you could do rise over run. You can do change in y over change in x. I don't care. So the slope is going to be -1. Okay, letter B. What do we got here? Find when g of x is increasing and decreasing. So g is going to be increasing when g prime is positive. So if you look at this g prime graph, we are positive from 0 to 6. And then g prime is going to be decreasing. Sorry, g is going to be decreasing when g prime is negative, which is going to be from 6 to 10. All right, next. Is x equals 6 a relative max, min, or neither for g of x? So g of x is going to have a relative minimum when g prime goes negative to positive. But you can see right here, at 6, g prime is going from above the x-axis to below. So g prime is going from positive to negative at x equals 6, which means x equals 6 is a relative maximum for g. And last but not least, is x equals a point of inflection for g? I like to teach it this way. G is going to have a point of inflection if the slope of g prime changes from positive to negative or negative to positive. So if you look here at 8, my slope is going from a negative slope line to a positive slope line. So 8 is in fact a point of inflection. So we're going to say yes, g prime of x slope changes, I like to say from negative to positive. Okay?